Hello and welcome to the next lesson in our series. This time your essential question is, how do you find empirical formula using percent composition? Now, in this statement, you should know what percent composition means. We have already learned this. This is where you look at a formula and figure out that it has X amount of sodium and Y amount of chlorine. Okay, so this is percent composition. Now we're going to do the opposite direction. We're going to use percent composition to find chemical formulas. Okay, so far this was known and this is what you're looking for. Now this is going to be known and this is what you will be looking for. All right, so let's dig in. The first thing we need to understand is what is an empirical formula. Okay, empirical formula, as you can see, is a simplified mole ratio. Now if you look at any chemical, for example H2O, okay, there is a ratio of the two elements of H to O is 2 to 1. And that should be pretty clear, considering that for every 2 atoms of hydrogen, you have 1 atom of oxygen. Okay, but this is a molecular formula. If you look at the example that I have on the screen, the example is CH2O, which simply means that the ratio of the 3 elements is 1 is to 2 is to 1. This does not tell you the identity of this chemical. You don't know what this chemical is. For all you know, this formula could be C2H4O2, or it could be C6H12O6. And don't get me wrong, this is not a made-up chemical. It is very real, and so is this. And so an empirical formula is simply the most simplified ratio of the elements. So if you know the empirical formula, all you know is what is the ratio of the elements. You don't know the actual number of the elements. Okay? To use a simple real-world example, we could say that the ratio of girls to boys in any school is 3 to 2. Simply put, it means that for every 3 girls you have 2 boys. You don't really know the total number of girls and the total number of boys. You don't know how many exactly there are. You just know their ratio. The empirical formula is the same concept. You don't know how many atoms of each element you have. You just know in what ratio are they present. Now, what do you need to find empirical formula? You can find empirical formula using any of these two. A, you can find it if you know the percent composition of the compound, or if they tell you the individual grams. So if they tell you that you have 2 grams of carbon and 3.2 grams of oxygen, okay, stuff like that. They will either give you grams or they will give you percentages. What we're going to do on the next slide is we're going to look at what are the steps you need to find the empirical formula, and it is very important that you follow these steps correctly in the right sequence. Now what I want you to do is go ahead and pause the video and note all of these down. Okay, so note down all the 4 steps, make sure that you get all of them and write all of them completely, and then we'll go over these one by one. You need to divide the moles by the smallest moles. What does that really mean? And step number 3 says that you are supposed to multiply the decimal number, in that case it was 3.499, by a whole number starting with 2 till you get a whole number. So let's go ahead and apply this rule in that problem. Now that you've noted down the steps, let's use those steps and try to solve a couple of examples. So this first example says a compound was found to contain 32.8% chromium and 67.2% chlorine. Find its empirical formula. Now, I would like for you to have your steps handy so that every time I mention to step number 1, 2, 3, or 4, you know which step we're at and what exactly is being done on the screen. And so what you're going to do is you are going to rewrite the percent figures as grams. Now, what does that mean? It means that since this has 32.8%, you will simply rewrite that as 32.8 grams. Similarly, you have 67.2% will be 67.2 grams, and this was chromium and this was chlorine. Okay, so now that you have grams, you will go on to the first step, which tells you to convert both of these to moles. To find the moles, simply take the grams and divide them by the molar mass. And after you divide, this is how many moles of chromium and chlorine you have respectively. Remember, these are the molar masses of the individual elements. Now that you have the 2 moles, go back to your steps and see what the second step says. The second step says that it means that between these 2 moles, this one is the smallest one. And so what you're going to do is you're going to divide both of these by 0.631 and figure out what answer you get. This one is obviously going to be 1, and the other one would be approximately 3. I know if you did this in the calculator, you got a number that looked something like 3.0 something, right? And for this particular case, you have to round to the nearest whole numbers. But there is an exception to this, and so we will talk about what that exception is in the coming problems. But for now, you get 2 whole numbers. You get 1 for chromium and 3 for chlorine. All you need to do is take these 2 numbers and use them as subscripts for your formula. And so you get Cr1, Cl3, and that is your final answer. Okay, so I would encourage you to kind of go back to the beginning of this problem and follow the steps along as I was doing and compare them to the steps number 1, 2, 3, and 4 that you wrote down, and see if you can figure out which step did I get this particular part of the problem from. Next example, you are supposed to find the empirical formula of a compound with 67.1% zinc and the rest is oxygen. And that part is pretty simple, because if you have 67.1% of one element, all you need to do is 100 minus 67.1, which should give you 32.9. And so what we're going to do is we're going to take this percentage, and we were going to write this as the grams. And so for zinc, you get 67.1 grams, and for oxygen, you get 32.9 grams. Going on to step number 1, it tells you to convert these to moles. And so to convert these to moles, I am going to divide these elements by their molar masses that I will find from the periodic table. And so what I got was for zinc 65.39 and for oxygen 15.999. So you perform these 2 divisions and you find out the number of moles. And so for these 2 elements, you get 1.026 moles of zinc and 2.056 moles of oxygen. And so all you need to do now is divide both of these numbers by the smaller of the 2, which in this case is the moles of zinc. And so this becomes 1.026 and this is 1.026, and see what answers you get. And so what I got was for zinc obviously 1, and for oxygen I got 2.00 something, and I can confidently round that as 2. Now that I have my 2 answers, I will simply use those as subscripts and my formula becomes ZnO2. Alright, so this is how you find empirical formula. In this next example, you have three different elements. You have sodium, chromium, and oxygen. And you're supposed to find the empirical formula. The steps do not change even though you have more than two elements. So you're going to set up your problem just like the last time. I set up the grams that were given in the problem, and I'm dividing them by the molar masses of the three elements that I got from the periodic table. So sodium was 22.990, chromium was 51.996, and oxygen is of course 15.999. And you will go ahead and divide these three and see how many moles of each you have. And so after dividing, these are the three answers that I got. Now remember what we did in the last two problems? We chose the smallest one of the moles and we divided all the moles by that number. In this case, sodium and chromium both have the same answer, and so we're going to divide these three numbers by 1.298. And after dividing, these are the three answers that I get. One for sodium, one for chromium, and 3.499 for oxygen. Now obviously, in all of the time you spend in chemistry, you know that when you look at a formula, you never have decimals as subscripts, which means we cannot write our empirical formula with these answers. And for this, you need to look at step number 3 of the steps that you noted down. Alright, so I'm going to start multiplying this number by 2, and luckily we get a number that's 7, and so this is a whole number. We don't need to keep going, but because I multiplied oxygen by 2, I also have to multiply the other ones by 2, and so what I get is 2, 2, and 7, and so my subscripts are 2, 2, and 7, and my formula is Na2 Cr2 and O7. Okay, and so we did 3 examples in this video, and when you come to class we'll do a lot more, and hopefully you'll get the hang of it. But do not get bogged down. This is kind of a complicated concept with multiple steps. You're going to need a lot of practice over this, okay? But please make sure that you watch the entire video and come prepared the next day. I'll see you in class.